So we're going to be looking now at module number 4, which corresponds to week number 4, which kind of officially, if you would, starts kind of that midpoint of our class. Okay. So, so you'll notice that we have our standard session 1, session 2, and the agenda items. So as we look here in session number 1, which is today, we're going to continue on here and look at chapter 8 in your Gajewski hardcover book, the tech drawing book. Okay. And I have the PowerPoint here in PDF form. I'm going to be pulling that up and we'll be following along with it. And then I'll be adding the lectures and such. The other part of this, the other part that goes with this is the AutoCAD chapter 11. And we will be moving in and practicing that as well. This chapter, or this section of learning plan number 4 is all about section views. Okay, so we're going to kind of learn about them in the tech drawing book first, kind of get the rules down, and then we're going to be practicing with the chapter 11 stuff in AutoCAD. Okay, creating them. All right, so so we're going to start first with our lecture. So I'm going to click on that PowerPoint presentation and we'll start. So chapter 8, this is in your Gajewski. If you wanted to open up Gajewski, feel free to do so. I'm going to zoom out here just slightly, but the illustrations are here. I think they correspond to the book. So first of all, sections. Why would we want to section something? Sections are reserved for when we want to look inside of the part. And why would we want to look inside of the part? Because I mean, sometimes we can get our hidden lines there, but especially when we have complex parts and there's a lot of like inner workings going on, it's very helpful to be able to look at it and see what's going on. And it's really exactly what we see here. We see this cantaloupe, and when the cantaloupe is just all, like normal, we buy it in the store, we can't see what's going on the inside, but we know there's something going on, right? And not until we actually slice it open and we see that inner core part where all the seeds are, we don't get that picture out here, okay? That's what sectioning does for us. We get to look inside of the part and get a better, more clear picture of the features. Now, we haven't started dimensioning yet. And we will, I think next week, module number 5, we'll start dimensioning. But one of the rules of dimensioning is we cannot dimension to a hidden feature. Okay. So if sometimes there's features that the only way we see them is in hidden lines in any one of our principal views, no matter what we do, unless we slice it open and we start looking inside. Okay. So sections are something that are like a common thing to do. All right. So when we create a section, we need to identify where we're cutting our part, where we're slicing our part. And that's by the cutting plane line. When we set up our template in AutoCAD, we did C-plane as one of our layers. That's going to be what we're going to use to identify this line right here. Okay. And it's going to have arrows on it. The arrows are going to point in the direction of the viewing of that section. Okay, so this is kind of where usually students will just kind of flip the arrows on accident, but it is a standard, so it's important that they're correct. So you'll notice here that the arrows on this part are pointing to the left, and the section view on the right is on that side, on the right. So we always say that the section view is behind the arrows, okay? Our arrows never point to the section view because what they're doing is they're cutting the material away and it gives us the line of sight that we're looking, okay? And then our view is on that right side, for instance, okay? Now, how I know this is a section view even before the cutting plane line, you'll notice that we have all of these diagonal lines. What do you think that looks like to you? That's where we're cutting through material. Exactly. And anywhere we don't have those lines is going to be like voids that are there. Okay. But now, instead of, you can imagine if this was a side view, this would all be hidden lines. Number one, we couldn't dimension to them. And number two, I think hidden lines are harder to look at than the visible line. So again, it adds clarity and it gives us a better picture of what's going on inside. Okay, so cutting plane line arrows pointing in the opposite direction, but they tell us which way we're looking at it. And then our view goes in back of those arrows, or points away from the view, if you would. Okay. So visible lines on cutting planes. So for instance, you'll notice that we have, in this case, we have what we call a full section. So it's completely cut in half. And you'll notice that there aren't cutting plane lines here. By the standard, by assumption, if there's only one section view that we're creating, we can just like not identify the cutting plane line, because the assumption is it's going right through the center as what we call a full section, which is the case here. It goes right through, and then our section view here is on the right-hand side. Additionally, you'll notice that all of the lines in a section view are visible. You'll also notice there are no hidden lines in a section view ever. Okay, no hidden lines in a section view ever. So even if there is something in the background that would warrant a hidden line, we eliminate them. They are not included in a section view. Okay. Now, placement of your section views, we've really kind of looked at this a little bit already, but you'll notice that over here, our section view is on the left-hand side of our view that has the cutting plane lines in. And you'll notice that the arrows are pointing away from the view that we're creating. They're giving us, like I said earlier, our line of sight. We're cutting down there and we're looking in that direction, and our drawing is of that. Okay. You'll see that in this case, we have a label on our arrows. So we have an A on the top and A on the bottom. Okay. And then down below our view, we have it identified as section. This is section view A-A, because that corresponds to the letters. If we only have one section view, it is not required to label the actual letters there or the view, okay, because it's assumed there's only one, okay? But when we have multiples, then we would have, for instance, a section BB and a section CC and you know, whatever it might be, okay? Now, again, this offers us that ability to dimension to features that otherwise would be hidden. So you'll notice that we have a depth here of these counter bores, and they would be hidden lines otherwise, and we would not be able to dimension to them. Okay, so again, it adds clarity and the ability to dimension to features that we otherwise wouldn't be able to. So labeling cutting planes, I already kind of touched on this briefly. If we have more than one cutting plane, it's important to label it, and then also, you know, label the view itself correspondingly. Okay, now section views do not need to be in orthographic projection, but then you do have to label them. So for instance, you'll notice that we have section BB here. It's looking in this direction, and it's actually down over here. They are independent views. So we can put those wherever on the drawing we want, okay? Again, if there's only one, or if there's a main one, like we have A here, it's usually gonna be in projection just for clarity, but B, any additional ones, they don't have to be, okay? But you could, I will say that. I probably would. I would probably tip this up on end and put it in projection like normally. Only if you don't have room to do that. And sometimes you don't. Sometimes you don't. There might be a view there, and then you do have to place it somewhere else, but then you have to make sure that you label the view. Okay. Rules for lines in sections. Okay, so we're going to look at the good case first. So we have this, I don't know, it looks like an adapter plate or something to me. It's round, it's got these holes in it. They have a section view going through, arrows pointing away, so everything looks good that way. And then here is our section view. So we're cutting through on that cutting plane line, and the diagonal lines are going to show us where we're cutting through material. Okay, this is a good view. Okay, so let's look at the ones that aren't so great. So over up on the right, I don't even like that they say it's a poor view. It's actually illegal. Like, we wouldn't do this. This is not acceptable even. So, so here you're going to notice that you see all these little gaps, and it's like it's not connected. Okay, so you do have to show these lines going across, because when you think about it, when I cut, those are still edges that I see, even if they're rounded, right? So notice that they're in down here, tops and bottoms, so that we don't have little floating pieces. Okay. The next one here is we do not put hidden lines in. We do not put hidden lines in. So there is this shelf that runs all the way along the back side. Section views, we add no hidden lines. We only focus on the area that we cut. So this would not be added here. And again, it's not poor, it's not to the standard, it's not acceptable. You don't do it. Okay. I would call both the top ones wrong. I don't know why they say poor. They're wrong. The next one here is when we have hatching, those internal edges become visible. We do not hatch to hidden features. Okay, so this is wrong. All right. Hatch is always in the same direction on the same part. So since this is one individual part, they have the sections going into the down into the left and then down into the right. That is incorrect. They have to all go in the same direction on a single part. And then additionally, you'll notice that they have some lines here that are, you know, kind of going across. There are no lines that go across. When we cut through material, it's like a face. Okay. So here is our correct, good, perfect section view for this part, right? Any questions on any of those? So again, no hidden lines are ever added. If you need hidden lines, and you add another view for clarity, okay? But in a section view, never any hidden lines. Cutting plane line style. So you'll notice here that our cutting plane line can be one of two ways, okay? There is hidden line, and that's what we set it up in AutoCAD. That is the most common, and it's per the newest standards, okay? But then, but there are also cutting plane lines that you might see as what we would call a phantom line, where there's two small dashes and then the long dashes in between, okay? That's another style that is acceptable, a little bit older style, but it's still okay, still okay. Visualizing cutting plane direction. So again, remember when we cut with that cutting plane, and the direction of the arrows, it's kind of like we're taking that material away now that's on that opposite side, and we're looking at the part as it's cut. That's going to give us our direction of our arrows. So again, we're cutting this away, and now we're looking in that direction. So you're going to kind of see where those hatch marks are going to correspond then to that view. Okay. Now over here, this one's wrong, and it's wrong because of the direction of the arrows. If you actually do want to cut and look in that direction, then our view needs to be on the other side. The arrows are always pointing away from the view. I look at that, okay? In AutoCAD, in the 2D AutoCAD that we're doing, you're manually placing those, okay? When you get to parametric software, it is a little bit more automated, but you always want to check it and be sure it's correct, okay? All right. Yep, and again, they should be pointing to the left instead of to the right. Section lining techniques. So you got to kind of hit a nice balance, okay? So and sometimes it comes down to exactly this. Does it look good? And part of what we're doing here is making sure that whatever we're putting out documentation wise is easy to read and easy to understand. So you got to kind of step back and say, does it look okay? So first and foremost, they need to be uniformly separated apart. And they also need to be kind of proportioned to the size that you are, you know, working with. And I'll show you in AutoCAD how you can change, for instance, that scale of how the hatching sits down. You're not going to be putting these in as separate lines. You're going to be actually hovering over an area, and it's going to recognize it, and then it'll show you a little bit of a preview, and then you can see what it looks like, and then you can click and it automatically goes in. So it is you're not drawing each one of these, I promise. Okay. If you are, then you're not taking advantage of the software. I'll show you that command. You'll also notice that it's going to start at 45 degrees, but we can also have control over this in AutoCAD, and we can change that. A couple of the no's or the wrongs down here, you're going to notice spacing has to be the same. It can't be irregular. Really probably more of a deal when it was manual and we had to do it, you know, by hand ourselves. Lines are too close. We don't want it to look like, you know, shaded or real dark. Varying line widths. Now that we're not going to have an issue with because in AutoCAD we have that set up. Lines too thick, we already have that set up as well. And then notice that these are overriding. They has to be within the confines of. This is where good geometry is going to make a difference, because if you have things closed up and they're single lines, AutoCAD's going to know exactly what you need. And if it's not, that's where you're going to have problems where it's not you know, hatching, it's not recognizing it. That means your geometry was not created correctly. So that's where you have to go back to, okay? And we'll talk about some of those situations when we start looking at AutoCAD. Additionally, section lining techniques here. So you'll notice that our angle here on this section is adjusted because now this is an angled feature. If we would be at the 45-degree angle, notice it kind of looks like the actual part and it's hard to distinguish. So what you want to do is you want to change that angle in order to make it look more normal. And it says here too, lines should not be perpendicular to an outline. Sometimes we can't avoid it just because of the nature of the feature itself. So that is a guide, I'm going to call that. But again, this is a depends on, but this is the best. This is the best in the correct way. Now there are different section lining symbols for different types of materials. Okay, so the ones that we're going to see most often are going to be cast iron, and they have steel right below it. Okay, the other ones, you'll notice that AutoCAD can be used for a lot of different disciplines, not just mechanical design. So it's used for like civil engineering. So they're going to be, concrete and sand, maybe even water. It can be used for the building trades. So you'll notice different types of wood. Rubber can come up in ours as well. So there's a number of different kinds. Now, don't get so hung up on this. This used to be a bigger deal, I'm going to say in the old days, if you would, where they would call out, especially when you had an assembly, what the material was, because they didn't have computer databases to keep track of that stuff. Okay, it was more manual. So now it was another clue of what this material was without having to look up on the individual part what it is. So not used quite as often, but there still is the standard out there. So the ones that we use most often, like I said here, are going to be the cast iron, and then also steel, and then there's aluminum as well. Now, there's different types of sections. We've looked just at what we call full sections, where they go across the full part and it's just a straight line. This is a half section, okay? This is where we're just going to look at a section of it to kind of give us that ability to see inside, but we're not going to look at the whole thing. So you'll notice what this looks like. So we're going to go down the center line here and just show the half section, okay? Notice that we see just one arrowhead in this case, all right? And then it goes down here, and here's our cutting plane line right there, and it takes out this chunk, okay? And then we're looking at it. Again, this is really to kind of give you the overall view of the part. Notice we still don't have any hidden lines on either side here. So it kind of shows you what you're actually going to see and what the inside looks like. Okay. So that's a half section. There are things called broken out sections. And this is where we want to look just at one area of a part. So for instance, we've got this piece right here, and we don't want to section the whole thing, but we want to see the angle that this hole is at. We can't get at it any other way. It would be hidden in any other view. So we want to be able to dimension that, and here it is. Okay, that's a breakout section. And notice they kind of just give a little breakout here, and you as the designer would actually draw that line in like that. Okay, it's intentionally not straight. Okay. There's also things called revolved sections. This comes up a lot when we have parts that are, in this case, you can see it's a cast part, and there's different cross sections at different areas. Instead of creating its own separate view on the drawing, we simply take it, we kind of break it out, and then we turn it 90 degrees so that we can see and dimension what that cross section looks like. Okay, we'll get opportunities to look at that a little bit later, but those are called revolved sections. Okay. Removed sections. This is where we section something, and you're going to notice that it's kind of a small part. In this case, it's blown up, and then they actually take it out of projection. Okay, so this is removed sections, and this is very legal to do. The key here, though, is that you identify a label for the section view. So we've got an A and an A in this case, and then the view is on the correct side. So you still have to be, what I say is, in back of the arrowheads. So you have to be on the non-pointing to side. You could not put that section view up on top of this still. Okay, you still have to be underneath here, but you don't have to be in projection, as you can see here. And the view is actually labeled with section. In this case, they abbreviated it with SECT, and then it's A-A. Okay, so that it's clearly labeled for that area. The next one is an offset section. So an offset section is to try to be a little bit more efficient, if you would. So instead of taking a straight line and going like right down the middle, what they're doing is they want to try to capture a couple different features to be able to dimension in one view. So here, this line is not going all the way through. This cutting plane line is starting at the hole. It's jogging up, always a 90-degree angle. It doesn't jog up at an angle. Okay, so 90-degree angle. And then it goes through the center of kind of this cutout slot. Then it goes up again through this, I don't know, whatever that is. And then it goes down through that last hole and then out. Okay, so this is called an offset section. So now when we show our view, still going to be in projection, but even though they're at different depths to one another, it offers us that ability to identify, you know, dimensions for things that we, again, otherwise wouldn't be able to. Okay. Ribs and sections. Okay. So this is kind of a little bit different, but it kind of makes sense when you look at it. So if we're going to do a section through a rib, okay. So if we look at the top view here, there's a rib. So that's going to be kind of like that diagonal portion that we see right here. They're calling it a web or a rib. And you'll notice that the section line is going all the way through and it's pointing in the opposite direction. So when we look at it, we don't section ribs. And we don't section them because they give the false impression that they're thick all the way through for the entire thickness. So if we look here, it's correct where it's cutting through, but it would give us the impression that it's this thick, and it's not. So ribs and webs are kind of special cases, if you would, okay? The parts that you guys are doing for me in AutoCAD for this learning plan or for this module do not have ribs in them, but they'll come up along the way. So we'll be revisiting that and checking it. The next one is an aligned section. An aligned section is where we have kind of a radius where we're not going straight down through the part. We're actually going then at an angle, and then we're cutting it away. And we actually rotate it around so that it's in alignment. So so you'll notice here that the cutting plane line comes down at an angle, and then the arrow points down and to the left. But notice the construction continues to rotate from there to what would be the center line if it was sitting, you know, right there. And then it actually projects that over. Okay. This is called an aligned section. Aligned section. Some more partial sections like we saw earlier. So full and partial sections, just looking at a section of it. And then notice we can see some revolves in here as well. And mostly those are used for, you know, space savers or for giving a, you know, a clarification on what something looks like. And then conventional break lines. So if we have a solid round part, we're going to notice we use these types of break lines on either side. Okay. This is going to occur when we have, for instance, a long part, and we want to try to get it on an 8.5 by 11 piece of paper. Okay. Or something shorter. And instead of making it super tiny on its cross section, we still want to be able to dimension it to a normal size. But instead of having it, you know, 2-3 feet long, we're just going to break it, and then we're going to dimension from either side. But we have to show that it's not to scale, and that's what break lines do for us. This is where we have a tube, and then this is where we have, this is a round tubular part. We can also do, you know, little jagged edges like this as well. Now, although we're not going to be doing assembly sections, I don't know if we'll get to it. We may, I forget. I think we might at the very end. So in a couple weeks, but when we do sections on assembly, sometimes we want to do this very same thing. We need to see portions or a part that is more internal to the assembly. You'll notice that I'm going to zoom in here, that when we have parts that are up against each other and they are sliced through, we still show that they are separate parts, but notice that the section lines are clearly different. So it differentiates from one part to the next. This is something that SolidWorks or even should say Creo does not do. So for instance, when you do a section line in a parametric software, these are the types of things that you have to clean up. You have to select those section lines, and you have to rotate them or change their angle so that they do look different. Otherwise, it's just going to put the same ones all the way through, and then it looks like it's a continuous part. Okay, and that's not the case. So so that is, I think that's that. I think that takes me to the end. Yes. So that's the book part, if you would, which is chapter 8 in your Gajewski book. It's going to be something that you're going to want to go back to and reference as you're creating the section views for me in AutoCAD. So I'm going to stop here, stop recording, and then we're going to be looking at chapter 11 in AutoCAD. So if you want to go there next, that's where we're headed.